So today we are going to learn about the SAP Analysis Tool. Okay. So there are few tools. Actually, apart from this also we have something called as ST05 and ST12. But as of now, for understanding, we will go through this SAP runtime analysis, code inspector, extended programming checks, which is also called as SLIN check, ST05 SQL trace, ATC checks, and performance tuning trips. Okay. So why we require the performance tools? We can write the code, get a job done, right? Any idea about it? Any Babu, Shrikant?
Maybe for the system purpose, the ECC
Sorry?
system purpose. Maybe because of for the ECC system purpose, kind of maintenance.
Okay, maintenance. Okay, any other thing?
So these all would be using to avoid unnecessary dumps in the ECC level.
Exactly, right. And
Yeah, so if the dumps are more, the system performance would be very less. So
right.
to avoid that, all the things we would
So
be.
not only dumps.
Yeah.
So
Not only dumps,
whenever
there might be
we are
unnecessary
right,
syntaxes and all the things. So if we do, it will consume more memory. If it is consumes more memory, then we would be in a stage of performance issues.
dumps. Yeah, correct. You both mentioned, for those things only we will be using this SAP analysis tools. So our first tool is, like I have mentioned here, SE30 or SAT. SE30 is the old and currently it is replaced by SAT. So we will go through each of the tools and see how it works, right? So first is the SAP ABAP runtime analysis tool. Okay. So this is like this is used to identify any performance problems in the ABAP program. Okay. This runtime analysis provides an overview of the duration and the performance of your source code. So what all benefits? So when we start this tool, I'll show you in GUI how we do. Like we will write a small program and then we will start this SAT tool, and I'll show you how it identifies the percentage of the time spent in database in contrast to the ABAP code execution. So the modularization units or modules or performs functions. So we have not used these things so far, but still I'll just show you how to analyze the internal table operations, right? So this is like during the runtime, it shows, just 1 minute. During the runtime, it just shows us how we can measure the performance and all, right? So and also there is one thing, if the graph contains green color, the program execution time is very good and very less. And if the graph contains red color, that means the program execution time is very bad. That means we are putting a load on the database. So let me show you in the GUI screen itself. So the the T code is SAT. You can also use SE30. But if you can see, there is a new transaction SAT for runtime analysis. So the new SAT or old SE30 transaction. So few additional features they have added in the SAT, and that is why we are using this SAT tools. Right now it has been replaced with this. Okay. There are two tabs. One is the measure and another one is the evaluate. Okay. Measure, when you say, like, it specify the description which application we want to measure, and in the variant we will give all the conditions, like what all programs we need and all these things we can mention. Okay, the function modules or any program if we want, so those we can evaluate it, right? So let's say what we can do, can do, we will create a small program and then we can start analyzing this SAT tool. Okay. So let me create a small program which it is definitely, this program is not of the optimum like performance, but just to show you how a bad programming can take much time, right? This is a conditional branches. This is not needed here. I have not written anything. The SAT, sorry. I'm declaring the internal table type of VBAK and VBAP. So first of all, we are using this select star. So we should avoid this select star actually. I'll tell you also what all performance tuning tricks whenever you are writing any code. VBAK. I'm taking it up to 100 rows as of now. Okay. And now, how to read that internal table? In the last class I said, correct? So we will use this into WAVBAK. And again, inside this loop, we are using select query, which is again issue into LSBB. And then I'm running it 1,000 times. Okay.
Why we are creating the work area VBAP1?
Yeah. So if you remember last time I showed you, right? Like in order to read row by row, so this internal table will contain multiple rows, right? So how will you
Right.
read it row by row? So
Right.
you will have to use either read query or loop query, right?
Mm-hmm.
Read will only read one single record, but loop will go through all the
Till
records. So
right.
in order to uh, yeah, in order to fill any values into the work area at the runtime, we need
Mm-hmm.
to go for this loop, correct?
Okay.
So I am actually writing right now a very poor piece of code. Okay, to just show you that if we write in this way, how it shows in the performance tool, how much time it takes, like this.
Okay.
Okay. Okay. So let's this. So if you see what I have done, I have created a select star first of all, up to 100 rows of VBAK. Then inside the loop, I am selecting this thing, and then again I am running a loop for 1,000 types. I am assigning the value of this VBAP. Sorry, this one VBAP, WAVBAP. to WA_VBAP2. Okay, and I'm running it. Correct. I'm not displaying anywhere. I'm just creating this program, and there is no meaning to create, select star inside a loop. But I'm just showing many people try to do it like as the beginners when we try to create program. And say for example, there will be a requirement where I want to display the results of like VBAK and VBAP inside one more work area, right? So in that case, what people do is they create a select query inside the loop. So what will happen? So as long as the loop will run, the select query will also run, and that will take a lot of processing time. Correct. So we should avoid these things. Rather, we should put select queries outside the loop. Oh, okay. VBAP1. Now what we will do is we will start this SAT tool. Evaluate immediately. So make sure that this evaluate immediately should be started. So this program is taken already. We don't need this function module. Okay. And we give this like if you want to create a variant you can, or else that is also fine. And now what you have to do is this evaluate, we can just execute it. And here also we have some execute this one. It will take some time. You're able to take little bit of time, and then we will go to check the result of the trace tool. Since I have given that do loop for 1,000 times, right? So it is taking much time. So if I would have not used that do loop for 1,000 times, it would be faster.
And one more thing, actually we don't get trace access right in production. So
No, we don't get trace action in the production. I think in ST05. So first of all, when you write the program in the development server itself, okay, development and quality server, there itself you have to check for the trace and all, right? And you should be aware of all the performance tricks. So ideally, we should not move the programs to the production and then check, because production is loaded with data. It might run in short dump, and it will create critical defects and issues.
correct.
So before moving it to the production itself, your peer review will also happen, right? In a program, in a implementation program, project.
Yes.
Always what happens is when you write a code, first it will be reviewed by your manager or a technical lead. Then peer review happens. A lot of processes happens. Whether this SAT tools, not ATC checks runs. Okay, whether you have adhere to all the naming standards and conventions. And in the ATC check, ATC is a very useful tool in that case, which is actually used by the program managers. They create a lot of variants in the ATC check. 20 times or something. Stop this transaction. Reset the move, evaluate. Meanwhile, let it run. Meanwhile, what we will do is I'll move on to that slim check and the extended program check, so that you will be able to see, because here we will be able to see all this rest of the checks. So if you see this, like there is something called AI or code inspector. So this is a static analysis of the quality of the code. Like it during this, once the code is completed. So if you see here, this is a runtime analysis of this code. Okay, so now I think is it done?
I'm not
It is
sure
still going
whether
on.
we would be getting this SCI inspector also, because in the integration standpoint, we would be having the XPI inspector, but that XPI inspector access would not be given to not even for one also, I guess, because it
No, no,
consumes
no.
more memory.
When you are into an implementation project, right? This SCI, extended program check, ATC check. See,
Mhm.
for this will come by default. This
Correct.
extended program check and code inspector. But this you have to set up. So in your particular program, there is a configuration which you need to do. It's quite easy, and generally the variants and all will be given based on the naming conventions and all, and based on that you can just run your ATC check. So the code inspector which I was telling, right, this SCI, so this will give you the analysis of SQL where clause of select, update and delete statement. You can read through this, like what are the benefits and advantage. But let me show you here. So if I go here and show you the first, let's go to this extended program check. In this actually you can run the select checks and accept this obsolete statements and cross programming check. You can click on the character strings and run this. Okay, so if you see this, there are like warnings. As long as we have warnings, those also you can eliminate. But if you can see, there are no errors actually, right? There are no errors. Sometimes what happens is like we can get some syntax check warnings or check on the load sizes or something like that. Those things will come in here. So you have to fix all these errors. Generally, before moving into the quality or the next, passing the UT test, we need to clear all this and we have to attach a screenshot in the UT document. Okay. So this is how, and if you see this warning, what they have 7, it is not addressed locally in the program. So I might have declared this LTVBAP, but I have not like used this LTVBAP anywhere. And then no reads are performed on the structure WAVBAK. Why? So if you see this is just a warning. But if you see this, I have just looped it into WAVBAK, but I'm not reading this WAVBAK. So it is just like assignment of the fields has happened. Nothing I'm reading. If I can just read the variable, or I can just write here, say, I can just use something called as write WA_VBAK VBLN. So for every loop, it will write that. Let's see if that warning goes away or not. Let's see. See, the warning went off. Correct? Because I made use of that work area. Yeah. So now it has come up. Correct? So if you see this result of the stress tool, okay, so this took this much milliseconds actually, this whole program to run. And if you see this, I don't know if you can see the whole screen. Is it visible, the screen, clearly?
Yes.
Yeah, yeah.
Yeah. So on the left side, you will see the split in where the program has spent time, and here you can see like most of the time is spent on the internal processing and not on the SQL statement. SQL statement means select query. Rather, it is spending more time on the internal processing, that loop statement, right? And the SQL statement can be analyzed from the ST0 files, which I was telling. But here the internal processing you can analyze, right? So this, like if I double click on the internal access on this right hand side, right? Here we can see that like which code blocks the most net and the gross time is spent. Correct? It does not always point you to the exact statements, but it can point you to the program which is causing the biggest delay. So if I like double click on this one and go here, So you can see that here actually it is taking more time here, right? In our case, like what I have done is I have used this do 20 times. Earlier I have used do 10,000 times, right? So that is actually a performance killer, right? This can be found. So this is how you will be able to understand that why it is taking like a lot of time in our program. Okay, this is how this SAT tool works. Now for ST05 and yeah, so we saw the extended program check as well. So this is the extended program check, and there is something called as the code inspector. Let's go to the code inspector, which is this one. So if you see here also, you will be able to see certain performance checks. It will clearly say you, right? So if you go inside this, these are the errors, right? This is a large table and we have not used a where condition. We'll go to this and I'll show you. See, so this VBAP is a large table. Why? Because it is an item table. So let me make it bigger. Okay. So what it says is, so what is the comment of this extended code inspector? So if you go here, so it says that analysis of where condition for select. In this actually the error is coming. And what is the error? That we are using a large table, but we are not using any where condition. Why we need the where condition? To avoid any unnecessary fetching of records which we don't want, right? So where condition will restrict which all records we want, that based on the condition we are fetching it from the records. So there are certain large tables like VBAK is a header table, but VBAP will be item table. So one sales order might have multiple line items. So this table is a huge table. So if we don't use any where condition, then it will take a lot of time. So that is why that error has come. Okay, so this is how you will understand from this code inspector that where and all we have to, and you have to clear that as well. Okay, so this is where it says the use of the statements that infer ominous database access. Okay, identifies the statements that bypass the buffering, drill through the support from the result screen to program source statement. Okay, but static checks cannot identify the relevancy of the piece of the code. Okay, so this SCI code inspector is a static check, and SAT was the runtime analysis tool. Now let's move to this ST05, and I told you about this extended program check. Then I will show you the ATC check. Okay, and then we will go for this ST05 check. So what is the ST? I am not sure if this ATC checks has been configured in your in this system or not. Let's see. Okay. So if I go to this ATC checks, so this is also showing you, but in addition to what it is, this ATC checks is actually running on an SCI tool. Okay. So if it's a code profiling tool, so what basically it helps in any implementation project. So the variants, you can create variants on this ATC checks. Okay, and it runs on an SCI tool. It also gives the same result as SCI tool, but in addition to that, it also displays if the particular piece of code is adhering to the naming standards or not. Okay, that is one thing. Then it will also like they would have set the priority errors, priority 1, priority 2, priority 3. So let me show you that. So I'm not sure if they have set here. See, this is a priority 1 error. Why? This errors, like generally what they will say you in the projects is, wherever you find the priority 1 and 2 errors, please correct it. Okay, rectify it before moving it to the next system. Okay, priority 3 errors can be neglected. Okay, or can be like omitted. But in case of the priority 1 error, here they are saying large table nowhere condition, the same thing whatever the SCI tool set to us, right? So here you can see which all are the priority 1 errors, fix that. Second is whether it is adhering to the naming conventions. Whether you have used in certain programs, they will tell that you have to use LIT for the internal table, but instead you have used something called as LT. So that also, those errors will also come here. So this is a naming convention error. Even if you are not putting a pretty painter, okay, where the keyword should be in the uppercase and the rest of the words should be in the lowercase, those errors will also come. Okay, and sometimes when you are using loop inside loop, okay, and they will also hint you to use, instead of work area, you should use field symbols. So all these settings and the variants will be configured by your managers in the implementation project, and you have to run this ATC check. Okay, clear? Right, so this is what it can be run in two different modes. One is globally by development lead for complete custom code basis, locally by the developer for one or more of his objects. Okay, so any doubt so far? Babu, Shrikant?
No, 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 no.
So now we will just see the ST05 performance trace. What it says, like as I said to you, so SAT was showing you the internal processing of those records and all. But for just to check the SQL statement, like if whether that is on the top performance or not, that ST05 is used for. It is used to record the database access, locking activities, and remote calls of the reports and transactions. And like it is a comprehensive tool for evaluation of the SQL statements, integrated tool for accessing all the DDIC information. So like let's now, what we will do is we'll create another program for ST05, and we will try to see how it works, right? So let me go and maybe what we can do is we can use the same program for our ST05 as well, right? So we have used this SAT demo, right? I will also maintain it. Like this is not only a GSAT. Let's make it SAT and ST05 demo. Okay, we'll use the same code for ST05 as well, and we'll see how it works. Or maybe instead of this, uh, let me create one more, like because I can use a call function or a function module, and that will help out. Instead of this is a city demo, and this. Same thing, but here there will be a little bit of twist. Like that. To pass this into the function module, right? So VBAP, and then I will do 2 10 times, okay, and I will call the function BAP. So for calling the function, there is something called as pattern. So here, this is the standard function module, BAP underscore. We will come to this function module, but just know that whenever we want to call any function module, we can give the BAP material underscore existence check. Right. Let's see. Existence check, right? So I gave just star just to know what is the function model. So we have this much, and what we will do is we don't need all this. Only in since we have this in the VBAP, we will have the material. So we will pass that material, VBAP material. Okay, but VBAP, yeah. So let's pass this, or we can give like I'll tell you what it does. So in the debugger, I will show you what this program is doing. Okay, and I'm just giving for each record. This is not again a best way to write a program. I'm showing you the worst way of writing the program and to display how the AC05 shows you. Okay. Let's make the pretty printer. Of course, this program is written very badly. So now what I have done is I have selected the all the fields from VBAK, and then I'm looping it. And in this VBAP, we have something called as material. This BAP material existence check, it will just check if this material is existent in the system or not, right? So we are passing this WAP VBAP matter, and this is the offset values actually. Okay, so a material number can be of what I think. Let's check what is the character length of that one. So it will take the first 18 characters of the material number. So it is character 18. Okay, that's fine. So it will take the first 18 characters of that material, and it is passing to that WebP material number. So now what we will do is we will run a SQL trace, and just to see how it works. So we will go to this like, let me let it run one GST5 time, and then ST05. Okay. So here, if you see, like in this SQL trace, you can like activate the trace for all the users, okay, by using this activate trace, or it is actually not needed because I don't want to run the trace for all the users. Rather, what I will do is this I can use this activate trace with filter. Okay, so when I run this activate trace with filter, so my username is there, and this one is there, right? Like the server name. Okay, and if you want, you can give the program name. I can give the program name. Okay, instead of running for all the program, or it is also not needed because whatever program I will just like run for that, it will take the trace. Okay. Let me do that. Activated filter this thing to trace a specific user action. Okay, and now I can start the. So I have activated it. Now I will start this program. Okay. execute this program. It will take some time. Okay. So always it is important that, like, the user which we are tracing, it is only doing this action and it is not performing any other action. Okay. Because all the actions will be recorded through this ST05 trace, and then it will make the analysis harder to read. So whenever you are running the ST05 trace, just make it limited to whatever you are running currently. For that, you just run the trace. Okay. So let's wait for a minute. Meanwhile, like these are all these are all the tools for which I will just show you how it works in the ST05. Then we will move to this performance tuning steps. Okay. So I was telling you, right? So what all things we should use? So first of all, this do not create or use any internal table with the header line, because already we are having the work area. Okay, so we don't need any internal table with a header line. Rather, you can use a work area and an internal table. Okay. And then second thing is, like, we should not use the select star from the database table unless we need it, right? Unless we need all the fields from the database table, we should not select star, because it creates a lot of load. Unnecessarily, you will fetch all the fields which you don't need. Otherwise, select the required fields alone, right? Then third thing is, like, whenever selecting from the master table, always compare the key fields in the where condition. You saw, right, in the extended program check in VBAP, it was a huge table. And if you're not using the key fields in the where condition, then it is taking either it will take a lot of time, and it will also give you the error in the extended program check. So we should always use the where condition. Like, do not write the select query inside a loop, which I was telling you, right? Inside the select query, if you write a loop, what will happen? For each loop, the select star will hit the database table. We don't want that, right? Because we should avoid hitting the database as much as we can, right? It will take more time to search and retrieve the data. Okay. And then similarly, don't use joins to combine two different database table. I told you, right? For joins, for wherever there is a case where we'll have multiple tables, in that case you can put join. But for two or like three tables, you can go for all entries. Okay. And then when you are using for all entries, we should always ensure, as I said, the prerequisite, that some data should be present in the internal table for which you are attempting to go for the for all entries. Like, if you remember, I made a for all entry for VBAK VBAP, and when I am selecting for the first query, I should check in that internal table whether the entries are there or not. Okay. And otherwise, what will happen is the for all entry will not work. Either rather, it will attempt to retrieve all the data from the source table. Okay. And again, like, we should not use the loop inside loop. Okay. There are few other performance tuning as well. Like, uh, we should not use the, like, if there are use of the aggregate functions, if we are using, right, at that time also, how to use, and then use of the views instead of the base table. So those things are there. You can go through Google and you can just check what are the need for the performance tuning and what are the performance tuning tips. Still running. It's still running. Just see that this is the disadvantage of bad coding, how much time it takes for the trace. And there is one more thing also. Let me see. Let it run. There is one more thing also I just wanted to show you. So, like this. So we ran that, right. Let me go to the evaluate. This is fine. So this is what I wanted to show you. In SE38, right, when you go for the evaluation, right, I was telling you, right, if it is in the red color, that means it is actually hitting the database system and it is not a good piece of program. Okay, so that is one thing which I wanted to show you. I have created any program or not. It's still running. Okay, let's do one thing. Like it might be running for all the traces. So let's stop the transaction. Like what we will do is we will. This one is there. So after the trace is run and you run the program, so you deactivate that trace. Okay, and after that you display the trace. Okay, it gives you this thing and you execute it. So begins after end. So trace may not be complete. Yeah, it is not complete because I have just run it halfway. So I'm just showing what is the available trace records. So let's go and see here. Yeah. So if you see, you can see that the total SQL commands, it took almost 37 seconds, right, in total. And the longest, if you see in here, so I think 203, 200, 215. Okay, so I don't think, so there are 5,000 records. So as of now, I could say that 215 is the longest time, 215 milliseconds. Okay. So what you can do is, like in case like I might find very large single SQL commands, then what I can do is I can go to this 215 and I'll just see the display ABAP location. Okay. So if you see this, hello, um, this BAPI which I was using, right? BAPI material existence check. So it took me that select query. Okay, so this is coming from the standard. Okay, and if you want to see that this is what is taking much time, and if you want to see the like summarized trace analysis. So instead, what you do, you go to the trace structured, structure identical statements. So you can see that there are 98 identical statements. Okay, so the first one is going to that BAPI material existence check, and if you see this second line, go to the like ABAP location, and you can exactly find where it is taking much time. See, this is where it took. So they select query from VBAP and this do 10 times. Correct. So when we clicked on it, the first line is anyway coming from the standard BAPI call, but the second line is coming where our we have run the bad programming, and the major delay is coming from that do 100 times, right? This is where it is showing. Correct. So this is how we will run the ST05 trace. And in case of the multiple application servers, so the development system normally we have only one application server, right? But productive servers might have more, right? In that case, whenever we are trying to analyze the performance issue directly on the production with the ST05, then we should be aware that the performance trace will be as per the application server. So we need to select the ST05 as the specific server. So if you remember when I gave this, just 1 minute. Yeah, so yeah, so when I gave this activate trace with filter, so we have to give that particular server. Okay, so the display will be as per the server. So that's all about it regarding the performance tuning and all the tools.